Really wish I was here tomorrow because tomorrow an old friend is coming back again. An old friend coming back again. So if that's going to come back, we need to know what the heck to write in the reasons column, and that's today. All right, that will be today. All right, here we go. Basics. At the top of the page, you guys have a definition of chord and a diameter. Can you put to the right of that, can you put your own circle for me? Put your own circle right there for me. I'm going to walk around. Can you please draw me, well, put your center in first now, put your center in. I want to see a chord and a diameter drawn in for me, please, as I walk around. A chord and a diameter. I want to make sure you guys know what those are because you're going to learn some facts about it today. Chord and a diameter. Please draw one in. Where's the diameter? Where's your center? Okay, so I know. Good. Clever, Bella. Pretty clever there. Two birds, one stone, as we like to say. Okay, good. All right, not bad, kids. Good, good. Clever, Emma. Very clever. All right, we're all good. So we all know what a chord and a diameter is. I feel pretty confident. So let's learn some facts. All right, first theorem. This may go into the reasons column. Congruent central angles, everybody. Here we go. Everyone have your circle right there. Can you please put a center in the circle I've given you in that box? Please put a circle in that, or you already have, or a center in that circle. What I'd like you to do as I walk around is please make a central angle now in that circle. Please make a central angle. If you need to go back and review what a central angle was, please do so. Let's go nuts. Let's do two central angles in the same circle. Let's go nuts. Start labeling the points on the circle where they touch, please. Start labeling the points. Label your center as a letter. So at least two central angles, please. Nice, nice, everybody. Very nice. I don't know what you named yours, doesn't matter. All right, ready? Here's what the first theorem is saying. If you're, and I know I didn't ask you guys to make them the same angle measure, all right? But if they are congruent, if your two central angles are congruent, so are your arcs, okay? So mark right now, mark your two central angles congruent, even if they don't look like it, who cares? So if two central angles are congruent, use my diagram right now. What two arcs are congruent? BC and AB. So whatever arcs are congruent for you, write that next to number one. BC congruent to, for me, BA, whatever your arcs are that are congruent. So does everyone understand that first theorem? If you got the central angles are congruent, so are the arcs. Done. And I won't have you do this, but we can go in reverse. If the arcs are congruent, so are the central angles. Central angles, all right? Central angles. All right, not bad. Everyone good on that first theorem? Any issues? All right, we'll hopefully use that in a proof tomorrow. Next one. You guys have a circle already there. Put a center in it. Name the center for me. This one involves chords. Please put 2 chords that look about the same length somewhere in your circle. 2 chords somewhere in your circle, please, that look about the same length. 2 chords. And label them with vertices. Label them. We all right over there? Okay, good. All right. Mark them congruent now. I know it's been a while since you've used these markings, but mark your chords congruent. And here's what this next theorem says. If your 2 chords are congruent, so are the arcs. Okay? So using my diagram, everybody up here, using my diagram, if those 2 chords are congruent, what 2 arcs are also congruent? Arc AB and arc BC. So whatever arcs you have on yours, go ahead and tell me those arcs are congruent. For me, it's AB and BC are congruent. And the reverse is true. If the arcs are congruent, so are the chords. Okay? Anything we say here, the reverse is true. Hi, Mason. No. Nope. That's just how I rolled. All right? But if they're congruent, the arcs are congruent. I don't care how they're drawn. All good on that second one. Hi, Remy. Segment. With the segment. Like you're talking. Yep, that's fine. It's a segment, so there's no fancy symbol for chord. Good question. Anything else? 2 more, huh? All right, you don't have to do any more drawings because I've done it for you. Huge, this one. Huge. Let's take our time, breathe. I'll assist you if you need help in reading it. A diameter. And they did, not mine doesn't, but yours does, huh? How about my diameter here, huh? Make D a little bigger there. There we go. Diameter, perpendicular to any chord, does what to the chord? Bisects it. All right, look at your diagram. Does everyone see diameter AB perpendicular to chord CE? Everyone sees that. So if it's perpendicular, the chord is getting bisected. Need somebody right now. What 2 segments up here are congruent then? Bisects the chord. What 2 segments that are congruent? Boom! 16. What are you doing? Where's the chord? Name the chord there, Thomas. It's getting bisected. Cut in half. Cut into 2 equal pieces. What 2 segments are equal? There we go. That's all I needed, young buck. That's all I needed. All right? EF is congruent to CF. You good, Thomas? Okay. Don't start arguing with me. I can hear the attitude already. All right? It's a joke. Calm down. And not only is the chord getting bisected, what else gets bisected? The arc. So now we know that arc AE, come on, arc AE is congruent to arc AC. Okay? The main piece is the chord getting bisected. That's where we're really going to use this theorem, is that the chord gets bisected. Yes, go ahead. I'm waiting, Anthony.
Can you have multiple chords?
What do you mean? If I drew another chord here?
If you had 3 more, would it do the same thing?
As long, they got to be perpendicular. All right, like if I do that, like if I pull this on you here and I make this into a chord, that's obviously not perpendicular, so it's not getting bisected. It's got to be perpendicular, the 2. Okay, got to be perpendicular to bisect. All good? Sam. No, you're not. We don't assume squat in here. Okay? I need to tell you they're perpendicular by giving you this symbol, or I need to mark it on your diagram. All right? We don't assume anything in here. Any questions? Last one. Last fact of the day. Oh, we used a big boy, big girl word here too. Theorem, I wish. Chords equidistant from the center, meaning same distance from the center. If you have two chords that are the same distance from the center, like take a look here. Everyone see chord BC and chord ED? How many units away from the center A is it? 8. If two chords are the same distance from the center, they are congruent. So in this case, chord ED is congruent to chord CB because they're both equidistant. And going back to Sam's question, we're not going to assume it looks like it. You'll see one of two things. Actual numbers on there that say 8 and 8. Yep, they're equal. Or what else could I put on here? Hash marks. All right, I'll see one or the other. All right, so if the chords are equidistant from the center, they're congruent to each other. All good. All right, here we go. Now the fun begins if it hasn't already. These are not proofs, yes. This, there will be a proof, yes, on Tuesday's quiz. This is not a proof. This is prepping you for a proof tomorrow. Here's what I want to know. I'm going to give you some facts. Tell me something in return, and we're going to write one of the theorems we've just talked about. Okay? So it's telling me what about the two circles? What are they telling me? They're congruent. Let's stop right there. If you remember day 1, when are two circles congruent? Look back if you need to. When are two circles congruent? If they're what are congruent? Diameter, we even scaled it down a little more. Radii. All right, so can anybody tell me segments up here that are congruent? If the circles are congruent, that means their radii are congruent. So here we go. Emma, shoot it off. PQ congruent to ST. Let's keep this train going here. Emma. No, the other one. Calm down. RQ congruent to UT. Anybody want to say anything else here? What are PQ and QR? Radii in the same circle. What do you know? Anybody know anything about all radii in the same circle? So what do you know about all 4? They're all congruent to each other. All 4 are congruent. So, and our reason, how do I know they're congruent? Radii, and I'm pretty flexible with the wording on this one. Radii in congruent circles are congruent. Yeah.
Is there like a symbol for circle so we don't have to write it out every time? Well, I mean, there's one.
I think the class is speaking for me, so I'll leave it at that. Billy. This isn't a proof. Tomorrow, yeah, you're going to have to write in just like the old days. But this isn't a proof. I just want to know as much as you can get out of this. All right? All right, let's go to this. PR is congruent to SU. If those two arcs are congruent, name something else has to be congruent based on the theorems we went over today. Dylan, let's roll. Here we go. PR congruent to SU. What theorem would that be? And I'm going to show you a shortcut. You don't have to write it all out, the theorem, Anthony, all right? Congruent arcs have congruent chords. So here's what we're going to have. Congruent arcs. Here's our good old buddy implies. Congruent chords. Congruent arcs imply congruent chords. I'm looking for one more here. One more fact if the arcs are congruent. If those two arcs are congruent, so are the first one we went over today. First one we went over today. So are the central angles. Name the two central angles up here. Angle PQR, congruent to STU. Congruent arcs, that's what I was given. Imply, what do I have here? Congruent central angles now. Always start out with what you're given. Comment down over there. No, it's not. I didn't give you any congruent arcs on that one, did I? All right, now I'm going to I'm not going to hold your hand anymore. Here you go. You tell me what you know. The circles are congruent. BC is congruent to KL. I'll take anything. I don't care what order it's in, anything you got for me. If you know that, then I appreciate the volunteerism, but I got to hear from 28. Nope, maybe tomorrow. 26. Anything. AB congruent to, say that again. KJ. I'm going to keep it going here, Jack. Which is congruent to AC, which is congruent to JL. Square root of 2, everybody, if you're wondering. I have no idea how that happened, but we'll go with it. And that's because radii in congruent circles are congruent. Oh, wow. Killing me right now, writing circles right now. Anybody else? Wrist? Anybody need, maybe I should bring ice in next week. I'll bring in ice next week. Radii in congruent circles are congruent. Shoulders even acting up right now. Yes. What do you mean what are major angles? Yep. You could say major arc KL is congruent to major arc BC. Yep. Because they add up to 360. So yep. Next, I only have one thing written down. We need a lot more here. 15. Yep. Oops, sorry, BC congruent to KL. Got it. Now, this is not the exact same thing I wrote over here. What were you given? What were you given? Because that's what I'm going to write first. You were given congruent chords, so that's what I'm going to write first. Congruent chords imply, what did Henrik just give me? Congruent arcs. Okay? And just for time's sake, I'm going to stop right there, but if you knew the arcs were congruent now, what else are congruent? Central angles, all right? We can write that in, but just to save some time, we're going to move on. All good? And then there's one more, right? Oh, nope, here we go. A little algebra time, find x. And how do we do it? Okay, ready? This really gets some kids right off the beginning, but this is what we're going to see every time. Everyone see this piece right here that I'm trying to find x. It may not be a diameter, but do you agree it's a piece of diameter? And it's perpendicular to a what? Chord. What's the theorem? If you have a diameter, a piece of a diameter, a radii, anything that involves the diameter perpendicular to a chord, what's happening to the chord? It's getting bisected. So each piece now will be 4 and 4. How can you find x? Pythagorean theorem. X squared plus 4 squared equals 5 squared. I'll let you guys solve for x. And then real quick, what are you finding for that length? 3. Okay, hold on though. So we get practice writing it. What was the major theorem you just used to solve this one? How'd you get the 4 on each side there? Let's write. Hey, this is gonna, and I understand. I'm not expecting greatness right away because it's a long one. So the wording might get mixed up. We go and take a shot at it, Remy. You could just say diameter. A diameter. So a diameter. Here you go. Ready? The old perpendicular sign. Go ahead, use it. Diameter perpendicular to a chord does what? Bisects the chord. There you go. I don't need the part about the arcs because I didn't bisect the arcs. A diameter perpendicular chord bisects the chord. That'll probably be the longest one this unit we use. Next. How do I find x here? Anything you can add to the diagram yourself there. Another 6. Why? And what do you know? If I'm in the same circle, what do you know about all the radii? They're congruent. We'll write that down in a second after we solve it. Now what can I use to find x? Pythag. And you know we're going to leave this in simplest radical form. Biggest, not the first one, the biggest one that goes into 72. Six, got it broken down. Good job. How about 27, broken it down? 8 can still be broken down. I know you did 9 and 8, right?
Yeah.
Okay, because there's a bigger one than 9. Because 8 can still be broken down. 36 and 2, yep. Square root of 36. All right. And let's go back to that fact you just gave me. How do we get there? How do we know this other piece here was 6? Okay, here's in a circle. In a circle, all radii are congruent. And I know all jokes aside, do I need to put in a circle? You tell me. Is that statement true? All radii are congruent? No, so that's why you need in a circle. All right, in a circle, all the radii are congruent. If you don't have that, that's not true. Last one. Got a lot going on there. We're actually going to use 2 theorems here. Well, first of all, what are these here? Chords. And they're both the same distance from the center, 7 units. What do you know about 2 chords that are the same distance from the center? They're congruent. So this chord is a length of 6, and this chord it must also be a length of 6. Let's get that theorem down first before we get the final answer. So how do I know it's 6? Chords. I'm going to force one of you guys to do it. Chords. What's the theorem say? 15. What's that theorem say? Why that's 6? Chords. Use the big boy, big girl word. There you go. Yeah. There you go. All right, how do I find x now? And you better have a fact to back yourself up. I know the whole chord is 6. How do I find each of those pieces? $19, any idea? So if I bisect 6, I get x equals? Yep, 3. And Dylan, want to do that theorem again? Diameter. Chord bisects the chord. Yep. You are learning, hold on, you are learning nothing new tomorrow on the video. It is taking all of these facts, doing a couple proofs and a couple more algebra problems. That's all you're doing tomorrow. Okay, nothing new. I am checking both homeworks on Monday. Tuesday's going to be the quiz.